The topic for our today's lesson is identity and access management at AWS. Long story short, and the minimum what you need to know to properly understand this class is that identity and access management helps you to manage your permissions in your AWS account. Some of them use root user, or some of them have already created your own AWS account or IAM user and gave it most likely administrator permissions. However, in real world scenarios in production use cases, giving full admin to everyone is not going to work. And we need to separate our permissions and give only minimal required permissions to each entity. Regarding entities, what can we have? In AWS, there could be IAM user, um, which represents either a real person or some external service, or IAM role. And a role is what we're going to use next, what we're going to use in our infrastructure very often, and we should be very familiar with it. And to demonstrate like the purpose of the role and what IAM role is, I need to create an instance, like regular plain EC2 instance, without this overcomplicated folder structure of level 1, level 2, and so on. So, and it's a good place, by the way, to demonstrate some additional Git, some additional tricks in Git. So, how do we? What's the purpose then of our commits? How do what's the usage of them? These are basically points in time, in our history. So we can choose any of these commits and basically time travel to 2 weeks ago when we first created our EC2 instance. How we can do this? We can use the commit hash. We can copy it. And in our Git, we can say git checkout our commit, and let's say the branch that we want to create. Let's say EC2 demo. And you can immediately see that hold on a second. And you can immediately see that our instance.tf is what we had back then, what we had previously. And basically, let's apply this Terraform code and check our instance. Actually, you know what? Let's create something slightly more relevant. Not this first EC2 instance, but instead this one with data sources. I will make some changes in our private IP and our public IP. So remember this public-private instance? It seems like it was ages ago, right? Let's run Terraform apply. And as usual, while it is creating, we can open the floor for any discussions, any questions that you might have regarding previous tasks. Let me know. Okay, then I would like to make one short and quick announcement. In case you guys are enjoying this class, I'd be happy to have private discussion with volunteers. It will be 30 minutes call where I ask couple. It's more like a feedback session. I'll ask a couple of questions. What motivated you to join this class? Well, how did you find out about me? It will help me better to know my students better and help me to position my courses better, and it will extremely help me to continue doing this, continue doing what I'm doing. So if you're interested in this 30-minute conversation with me, uh, just send me a message directly in Slack, and we'll arrange some time with you. And I will extremely appreciate that. This information will be very insightful and valuable for me. Everyone are extremely silent today. Am I audible at all?
Yep.
Okay, yeah, cool, thank you. Right, so we have created our AWS instance. Let's SSH into it. Oh no, it's in the wrong region with the key that I might not have. That's a bummer. We had to recreate it. I am extremely sorry for that. In case someone forget, we had US West 2 over here, and previously there was an issue where we created in this region, but I didn't have a key created then there. So I had to recreate this in US East 1, and now we're repeating same thing. Luckily, it was destroyed really fast. Now let's apply and recreate our everything in the different region. Okay, very good. Now our instances are in the right place and we can move forward. So let me first SSH to it. I had to, I mistyped the IP address. Let me SSH to it one more time now. Yeah, now it is working. Now the question. Let's say we have an S3 bucket, right? So let me create one. Or we'd rather use this one. Yeah, example 1, 2, 3, 4 ASD. And I have an EC2 instance. Let's imagine that we store some backup on this bucket that we need to restore into this virtual machine, into this instance, or upload something to this bucket. here is the task setting, right? So, and I'd like to hear some opinions. If you already know the correct answer, please don't yet jump in, right? But the overall question is, how could we transfer a file from this instance to an Amazon S3 bucket? Yes, Sabina.
Sorry, are they? Is it? Do you mean from a different? Are they both in the same account or different account?
Same account. There is a message from Sanjeev in the chat saying we can use AWS CLI. In our case, AWS S3 commands, and this is totally right. So from within our laptop, we can run, for example, AWS S3 ls, and it will give us this list of the same bucket. We can run AWS S3 ls and, for example, see the content of, let's say, our remote state bucket. Here we have our TF state files, right? But if we run AWS S3 ls from here, we will have an error unable to locate credentials. You can configure your credentials. So why is that? What should we do? Second question. Piyush?
We can create a user in the S3 bucket and then provide access from here.
Okay, first step, create a user. Second step, provide access. Can you elaborate more what you mean by provide access?
I mean, for example, that
Run
user.
this command, yeah? Create access secret key, provide access key, secret key, put it into our instance, right?
Or maybe create a role, possibly.
Yes, very good. And that's, yes, that's exactly. And exactly like Abina suggesting in the chat, we can use IAM role. So role, I'd rather, in Google in Google Cloud there is very good term, there is very good definition called service account. IAM role is some I would say entity that is assigned to object in AWS, which is not representing a user or third-party app, that will have some certain permissions and some certain actions, which means we can assign these, we can create a role, assign it to the instance, and even without having to specify access and secret key, we'll be able to connect to our instances. And let's do exactly this. I'd say I'd create one more file, IAMTF, and here we'll create a role. But we'll start not with the role, but with the policy. Resource, AWS, IAM policy. Policy is the document written in JSON that explains, that describes what you are allowed to do, what you are not allowed to do. And let me copy paste the entire document to here. What it means? It means we are allowing all actions for Amazon S3 across all resources. And now we can create a role. And the role is the actual entity that will have this policy assigned to it. And the question to you guys, I have written two policy. I have written policy 2 times, both here in IAM role and also here in IAM policy. Why is that? Why do I need 2 and also 2 different policies? Can you tell me that? Any guesses? Any assumptions? So, okay, let me uncover this. Yes, Piyush.
Yeah, it's like from which instance this role is being used, or maybe accessing the S3 bucket, possibly.
Kind of yes and no, but let me clarify like more precisely. This policy is explaining what actions are allowed for an entity that is having this policy assigned to it. And this policy, this is called assume role policy, explains who can assume, in other words, who can use this role. So role can be used by different entities, but like almost any AWS service can interact with other services on behalf of a role. And here we're explaining that this role is designed to be used by EC2 instances. If we were to use, for example, Lambda functions, instead of EC2, we'll have Lambda here, and so on. And a couple more steps that we need to do is we need to assign this role to assign this policy to this role. And there is one more resource called AWS Instance Profile. What it does is it's more like legacy thing about how it was before and how it was now. When you create IAM role manually, it will create an instance profile for you. But in API, you have to create a role and an instance profile. It's kind of a connector between your role and between your instance. And in our instance TF, we need to, let me recall, I don't remember the exact property. Let's refer to Terraform documentation for that. It should be called IAM instance profile. Let's try that. IAM instance profile, and this one. Perhaps let it be IRN, but maybe ID. We'll change it later if we receive an error. Let's format our code and run Terraform apply. And I see a question in the chat. Abina asking, can a resource in another account access this policy? For example, EC2 in another account. Yes, but only if you explicitly allow another account. You might want to read more about cross-account policies and cross-account IAM roles in AWS. Invalid instance profile name. Okay, probably instead of IRN, we should provide instance profile name. Let's try this in our instance. Okay, very cool. We have our instance modified. And when we refresh it, let's see where can we check in the UI. Details, IAM role or Lambda, our IAM role. And if you were to compare it with our private instance, you can see that there is nothing in this part. Now, when we go to our instance again and run our AWS S3 commands, we're now able to see our list of buckets without having to save and hardcore credentials anywhere. EC2 instance, AWS CLI is automatically discovering that we are running on an EC2 instance. EC2 instance checks which IAM role it is assigned to through instance profile. And in the IAM role, we'll have some certain set of permissions. So let's destroy for now and find out some better way of how we can apply our IAM roles in our latest and greatest configuration in our tip of the iceberg in our recent commits. Let me think how to better approach this. In AWS, there is a feature called Session Manager. So instead of exposing our instances publicly, we can go to SSM, Systems Manager, Session Manager. Over here we are. We can just press Start Session, and it will automatically show the list of instances. Doesn't matter if they're public, private, if they have a key, or if they don't have a key. Anything will be accepted. But there is a prerequisite. And this prerequisite is to have an IAM role with proper permissions assigned to the instance. So what we're going to do next is we'll create our SSM role and attach it to our autoscaling instances. We'll remove all things related to SSH so that we can connect only from our AWS UI in a most secured way, so we don't even have to expose anything outside to the world. And while I am changing these, let's run Terraform apply in level 1. And in the meantime, we can continue editing our configuration. So I'll put IAM.tf to here. And sorry, give me just a second. I need to connect my power. I need to connect my battery. Otherwise, I'll be disconnected. Just a second. Okay, I'm here again. So we don't need S3. We are not using S3 in our project, in our auto scaling group. We'll keep this and the rest of it, and we'll attach this line to our IAM role. And let me explain what it does. In AWS, if you go to IAM, if you go to IAM, there are different kinds of policies. For example, there is customer managed. That's the one that we created ourselves. And there is AWS management. AWS maintains set of predefined policies that if there are changes, updates these policies. So we can reuse like existing things for commonly used cases. And there are plenty of them. One of them is AWS policy for SSM. Or policy for system. Yes, it should be called EC2 role for SSM. Just like this. So what we'll have is same role, but proper policy that allows SSM access attached to it. And immediately, so we don't have to run apply multiple times, I'll remove the key. We no longer need it. I'll remove SSH rule. We no longer need it. And yeah, that's it. We are locking down our infrastructure and making it as secure as possible so no one can even try. And we don't need this policy attachment since we no longer have main policy and we're using managed policy. Run Terraform apply. Let's check. Maybe we have our instances already. We don't need to wait until load balancer gets up and running. Yeah, we have them. No public IPs. So we can go check the role that it has. Why it says it has no role? Because we forget to assign it to our autoscaling group. Yeah, that's a mistake. Let me check, refer to my notes 1 second. How can we do this? We can do this by editing the property of our instance profile of our autoscaling group. So autoscaling will have very similar thing, not autoscaling, actually launch configuration. Very similar to what we had with our regular standalone EC2 instance. IAM instance profile and the name of this instance profile. Let's try this. And actually I will comment out these two and first destroy. Destroy these two resources by deleting them from the config and run Terraform apply, and then recreate. Because otherwise, that's you might try that at home if you would like, and you'll see how painful it is to recreate a launch configuration for an autoscaling group using Terraform. It will you'll encounter different sources, different kinds of race conditions that you can't even imagine. And I'll help autoscaling to destroy everything faster by manually terminating instances. And maybe even this autoscaling group as well. That's, I would say, a very obvious disadvantage of live classes, especially ones related to things such as Terraform. Very often we have to sit and wait until something is applied or something is destroyed. So please, I wish I could, I wish this could be faster, but don't be mad at me.
It's an outrage, Vlad. Outrage.
I think I will do this. Don't try this at com. I will remove the auto-scaling and launch configuration from state, so Terraform will completely forget that these ever existed. And same for the launch configuration. It will still spin and hang in the deleting state, but we no longer care. Eventually it will delete. We don't have to sit and wait until this is done. But AWS will not allow us. No, actually it will allow, because we're using a thing called name prefix. And our launch configuration will have our lambda and random hash at the end. Let's check and see. Oh, by the way, it deleted successfully already. Yeah, probably once we recreate it. Here we are, this one. Actually, not that random. It has at least date in it. And then we can return everything once again and recreate it one more time. And this time with the proper launch instance profile attached to the launch configuration. Terraform apply. Over here we have instance profile. Hit yes. Apply completed. Very good. Let's refresh everything. Yeah, we have our new launch configuration created with different hash code. When we go to instances, we have an instance having this IAM role, which is called Orlando. But this time it has the AWS managed policy called Amazon EC2 role for SSM. And when we go to our systems manager once again and find session manager, what we can have is these two instances. We can choose any of them. And what we'll get is this web-based terminal. Oh, sorry, too much. And here we are, inside our EC2 instance. So Sanjeev, could you please, your question is very good, great, excellent, but could you please repeat it out loud so everyone can hear?
Yeah, so till now you showed us how to connect with the key, right? SSH key. So question was, is this the default standard for prod-based deployments in the real world scenario that everyone uses SSM instead of SSH keys?
Yes, we are trying to avoid SSH keys because it's external. You have to expose SSH, and this increase risks. Overall, yes. If you need to SSH, it's better to use this session manager. That's right. But session manager is not the only ultimate solution. There are different ways for that you can use to sneak into your node without exposing SSH to open world. Piyush?
So, but this is more relevant or more applicable for the applications they wanted to access rather than users, right?
I can't imagine scenario where your end user needs access to SSH. What is meant by users?
I mean, for example, if a web-based application wants to access some another instance or S3 bucket or something like that, then only SSM scenario would be best fitted rather than.
So you should not confuse IAM roles and SSM. SSM is slightly different topic.
Okay.
However, yes, it uses SSM. So if you need your instance to have some set of permissions, you need to assign IAM role. Does not matter which permissions. In a previous scenario, we had S3 bucket. In this second scenario, we have SSM. And SSM is basically an agent that's running on the instance. And this agent requires some certain permissions in AWS to assign to the role. Please, don't. I think I had to explicitly tell this in advance. So IAM role and SSM are different services, and SSM is reusing functionality of IAM roles. They are kind of connected that way. Hope this makes sense.
Yeah, sure. Thanks.
Okay. In the meantime, let me commit everything. Yes, Boris.
Just real quick, the SSM agents, I'm assuming, are preloaded onto the AMIs, right? Amazon.
SSM agent is preloaded in Amazon Linux AMI. And if you're using any other AMI like Ubuntu, CentOS, or whatnot, you need to also install it as a separate package into your operating system, usually
Got
using user data.
Got it. Thank you.
Sanjeev, yes?
Yeah, for the demo, you showed one of the commits, right? You went back in time using
Yes.
Git. So if you just read to use a file, so did you delete the branch after the demo branch, or it's still there? I mean, the main doesn't change, right? The main changes are still
Main doesn't change. When we get back in time, it kind of creates the so-called detached head scenario.
Okay.
Let me show it to you. So hopefully it will not take awful lot of time. And yeah, we are finished for these sessions. If you don't have any questions, the rest of the group, feel free to drop. Regarding content, we are good. Or only if you have a questions and when you want to discuss anything else, feel free to stay with us. Okay, yeah, real quick, let me visualize that for you. This will make sense, makes sense. So we have our commits, right? Commit, we imagining them as a sequence of changes, right? One, two, three. Okay, never mind. And this will be something like that. Yeah. 2 branches. And there is a concept of head. A head is the pointer to what is actually supposed to be displayed in your file system. And checkout is basically moving this head. We can say check out some different branch, and it will switch this head into here. but it will still remember that there is some alternative version in a different branch under the different sequence of parent commits. So we can switch this between our branches. Checkout -b creates a new branch and also switches head to it. And same thing that I demonstrated previously when we started, head can allow us to get back to the previous commit or to this commit or to that commit. But still, again, it will still, of course, keep track of everything that was here. And we same thing, we switch to here, we can back here again or here, anytime we want in any direction. Yes, Sanjeev.
Yeah, so thanks, Vladimir. So you just did git checkout and the commit ID, right? Where you want to go back in time.
Yes,
Is
git
there-
checkout and commit ID, that's right.
There's no need to create a branch along with that, right? As long as you simply want to
You
point to a particular commit.
If you want just temporarily, you can do git checkout and commit ID. But if you want to also create a branch out of this,
Got it.
out of this commit, you can first switch your branch to here, and after that, nothing prevents you from doing git checkout -b and branch name, and it will create this new branch for you like this,
Okay.
and you can continue moving forward from there.
Yeah, got it. So there's a git stash, right? A little bit confusion. So
No,
that's
git stash is a different thing, and I'm not comfortable myself for git stash. I'm using different less magical ways of achieving functionality of git stash. Git
Okay.
stash is when you have some file that you don't want to commit, but at the same time you don't want to lose it, but you need to switch branch.
got it. Thank you.
And you're saving it to stash, and it's like a vault, like a temporary vault. Okay, yeah, and so I don't forget, I merged everything, and never forget to run Terraform destroy. Yeah, and this one is good. Any other questions? If no other questions, I wish you have a great rest of your evening and have a good day. And Sanjeev, you have a question.
Yeah. So firstly, I mean, during the demo, you showed us the instance profile ARN